Okay, today we're going to go ahead and do section 9.2, graphing hyperbolas is what they're called. Okay, so first let's talk about what a hyperbola looks like. Okay, and again, you're going to have two different types of hyperbolas. Okay, the first one is going to look like this. Okay, so this is going to be x squared over a squared minus, so a couple things different than the ellipse. First of all, instead of a plus, there's going to be a minus in between them. Alright, these are called your vertex. This would be your foci. Okay, and then this thing is called a transverse axis. We can also have a hyperbola that opens like this. This time, oh, hang on, go back to the first one. That's your transverse axis, sorry. So please make sure that when it opens up this way, your transverse axis is the x-axis. Please make sure you fix that. Alright, so here my y-axis is my transverse axis. Same thing, this is called a vertex. This would be your foci. So again, notice that the foci are in the curve. So the equation of this hyperbola is y squared over a squared minus x squared over b squared equals 1. So again, the next difference you notice between the hyperbola and ellipse is that a squared and b squared stay. Y and x will change places. So when y squared leads, it's opening up this way. When x squared leads, it opens up either side. Okay? Let's go back to the first. I want to add one more thing. Y is equal to plus or minus b over ax. This will give you your asymptotes. Okay? So in our other one, it would be y is equal to plus or minus a over bx. Alrighty? So, let's go ahead and get into a couple of these. So, example 1. Find the vertices, foci, asymptotes for each of the following. Then graph. Alright? So you're going to be asked to find the vertices, the foci, the asymptotes, and then graph. And I'm going to go ahead and start a fresh page when I do this next one. Number 1, x squared over 25 minus y squared over 16 equals 1. Now, just like the ellipse, sometimes it's easier if we go ahead and graph it before we do this information. Now again, we're going to want to put this on graph paper, but for right now, since we're taking notes, I'm just going to go ahead and graph it in the notes. Okay, so the first thing we have to do is figure out, does this hyperbola open like this, or does this hyperbola open like that? And since x squared, it leads, we know that it's going to open like this. Okay? Alright, so I'm going to go ahead and jump down here and at least get this for a minute, because this is going to help us quite a bit. Alright, so it's y is equal to, since x is going to lead, it's going to be plus or minus b over ax. Alright, so y is equal to plus or minus, remember this is always a and this is always b in a hyperbola. So I'm going to take the square root of 16 is 4. The square root of 25 is 5x. Now, how that's going to help you is, let's go to this graph. We know that the center is at what? Let's go ahead and say that I want the center too, just for fun. Alright, do you agree the center is at 0, 0, since there's no parentheses with these guys? So now what we're going to do is go ahead and graph these asymptotes. So I'm going to go a rise of 4, 1, 2, 3, 4, and a run of 5. And I'm going to go down 4 and over 5 this way. Okay, so that's one of them. Now, that would be the positive. Remember, we could also do negative. So I could go down 4. So that would be negative followed by a positive movement. So down 4 over 5. Or I could go up 4 and negative 5. Okay? Now, you notice these, if you look at just these points, that's going to make you a little rectangle. And let me get a different color so I can show you what that looks like. Can't seem to find my pen pack today. You don't... Alright. So now what I know is that my hyperbola is going to do this and here. So now I automatically know the vertices. So the vertices are at 1, 2, 3, 4, 5, negative 5, 0, and 5, 0. So let's talk about how to find the foci. So remember yesterday, to find the foci, we dealt with c squared, a squared, and b squared. So today, notice that this is a minus sign. So when I do the foci, I'm going to do c squared equals a squared plus b squared, where yesterday we did minus. Alright, so I'm looking for c squared. I know a squared is 25, plus b squared is 16, so c squared is equal to 41, so c is plus or minus the square root of 41. And again, you can certainly grab your calculator and type in what the square root of 41 is. Okay? So the square root of 41, if I type it in my calculator, is about 6.4. So I can go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, and a little bit. There's a foci, and here's a foci. Okay? And again, I like to do my foci with little x's, just something different. So to write them, I'm going to say it's negative square root of 41, 0, positive square root of 41, 0. And you've survived your first hyperbola. Alright, shall we try a second one? Let's do y squared over 9 minus x squared over 16 equals 1. I'm going to go ahead and do 5 on each. So, first thing we need to do is decide how this baby's going to open. So it's either going to go like this, if x squared led, or like this, if y squared leads. Well, y squared's leading, so I know it's going to open up this way. Okay? Alright, so again, let's go ahead and talk about a center, the vertices, the foci, and the asymptotes, and that's where I'm going to start. Now on this one, because it opens the other way, let's try a different method. I don't want to overwhelm you guys with having to memorize a whole bunch of stuff. Do you agree that this says on the y-axis go 3? 1, 2, 3. And here, down 2, 3. And on the x-axis go 4. Now make your box. Maybe that'll be easier for you. That way it's not one more thing we have to memorize. Alright, so did you see how I did that? Again, I took the square root of 9 and said, hey, I got to go 3 and 3 on my y-axis and 4 and 4 on my x-axis. So what you end up getting are those for your... So now instead of doing a formula, how do I get this slope of this line? I just go up and over. So I go up 3 over 4. So it's plus or minus 3/4 x. That way I don't have to memorize another formula. I like that a lot better. Okay, do you agree this time your hyperbola is going to open this way and this way? Because y led. So let's get the center. The center is at the origin, 0, 0. The vertices I know are at negative 3, 0 and 3, 0. So now all I need to do is my work to get my foci. And so my formula for the foci is c squared equals a squared plus b squared. So I don't know my c squared, but I know my a is 9, or I know my a squared is 9, and my b squared is 16, so c squared is equal to 25. Take your square root. So c this time is nice and easy. It comes out as positive or negative 5. So now I can go up 5 and down 5. So my foci are at negative 5, 0, 5, 0. Okay? So I'm going to do one more with you, where I'm going to start you out. So example 2, write the standard form of a hyperbola with a foci at 0, negative 5, 0, 5, and vertices 0, negative 3, and 0, 3. Okay, again, I personally like to graph these things and then figure it out. But that's a preference thing. Sometimes people don't like to graph, and that's certainly okay if you can do it without a graph. But you know what? I figure it takes me just a little bit of time to be able to graph this, and then I don't have to think so hard. So for me, it's a nice trade-off. Alright, so I have a foci at 0, -5, and at 0, 5. And I have a vertice at 0, -3, and 0, 3. So I know that it looks something, if I were just going to sketch it, it looks something like that. So the first thing that this tells me is that y leads. Okay, that's the first thing I got. So now I need to do a little bit of work here. Well, do you agree that c squared is equal to a squared plus b squared? Now my question is, we know c squared, because c squared is what? C is the foci. So we know the foci are at -5 or 5. It really doesn't matter which one you pick, because no matter what you put in when you square it, you get positive 25. So now what we need to do is figure out who's A and who's B. Okay? Well, y is leading. And what is the value on the y-axis for the vertice? 3. So that has to be your A, right? Because in a parabola it goes, in a hyperbola it goes a squared and b squared. So let's let A be 3 squared. And again, if I wanted to put in a -3, it doesn't matter, because 3 squared is 9. Now I subtract 9. I get 16 is equal to b squared. Do I really need to take the square root? No, because now I know that here I'm going to put a 16, and here I'm going to put a 9, and I'm finished. Okay? So the last thing I'm going to go ahead and at least set up for you is how to do one of these, at least get you started thinking about moving the center again like we did in class. So, example 3. Same thing as the first one. Name the center, vertice, foci, asymptote, then graph each hyperbola. So what we learned yesterday with the ellipse is that you just end up making life a little bit more difficult when you shift the center. Okay? It's going to just mess up your foci a little bit. And in this case, it's going to mess up our asymptotes as well, big time. So first, before we do anything, let's name what our center is, because we can go ahead and get that right away. So remember, when these fellows come out of the parentheses, what happens to their sign? This -3 becomes 3, and the -1 becomes 1. So I've got my center. Again, I'm going to go over here to the side, and I'm going to go ahead and so 3, 1. So there's my center. Now, I know that this is going to open this way because x squared leads. And I'm going to go 2 units from that center in both directions horizontally. 1, 2, 1, 2. And I'm going to go 1 unit, right, the square root of 1 is 1, up, and 1 unit down from my center. So there's my little itty-bitty box that I'm now going to use to make my hyperbola. Okay, so I know those are my asymptotes. We already said this parabola, or hyperbola, I got parabola on the brain today, goes like that. Okay, so I've made the sketch of him now. So let's go ahead and get our vertices, and then tomorrow we can pick up this example in class and talk about how to do his foci. Again, because he's opening along the X, would be this point, which is 1, 1, and this point, which is 1, 2, 3, 4, 5, 1. Alright, so we'll go ahead and pick up this lesson tomorrow, and you guys have a great evening.